I'm going to go ahead and go over a quick lesson of 5.1. And this is just a recap if you missed class, if you weren't in class at all for some reason. This is kind of just a recap for you to recap 5.1. So let me get this set up real quick for us. So the first thing we did in 5.1 was that we simplified expressions. So here are the type of expressions we saw in 5.1. And what we were doing when we simplified expressions was using our operations of exponents. So I gave you a chart that had all of the different properties of exponents. So that's what I'm going to use to solve these three examples. So when I'm solving these, I'm looking at letter A. That's the first one I'm going to go ahead and do. I notice that I have negative exponents. So with these type of problems, there's a lot of different ways that we can actually solve these. So one of our exponent rules tells me that if I have negative exponents, I need to make them positive. And to make them positive, I just need to change their location. So I'm going to start there with letter A. So my 2 doesn't have a negative exponent, so I'm just going to rewrite it. But my x to the negative 3, that's a negative exponent. So I'm going to rewrite it so that it has a positive exponent. So now I'm going to put it on the bottom. And because I did that, it is now positive. Now y to the 3rd, he's already positive, so I'm just going to leave it. And negative 7, it's a negative number, but it's not a negative exponent. So I'm just going to rewrite it. It's going to be negative 7. X to the 5th, positive exponent. But my y to the negative 6, that's a negative exponent. So I'm going to bring that down to make it positive. So far, we've done pretty good. We got rid of all the negative exponent. The next issue that we have to face is that we have more than one of the same bases, meaning I have a y here, and I have a y here. I have an x here, and I have an x over here. So I got to simplify those. So we could go ahead and we just start by subtraction. So I'm going to leave the 2 alone. And now because I have y to the 3rd and y to the 6th, my exponent rules tell me that I subtract exponents. So I'm left with y to the 3rd because 6 minus 3 gives me y to the 3rd. Okay? And we leave the y on the bottom because that's where the greater number was. Then I'm going to do the same thing with my x's. I have x to the 5th and x to the 3rd. So I'm going to subtract 5 minus 3. So I'm left with x to the 2nd power on the top. But I still have that negative 7. So I'm just going to rewrite that negative 7. So we're almost done here. I can combine by multiplication my 2 and my negative 7. So 2 times negative 7 is negative 14. And then everything else stays the same. So for this problem, we did the law of exponents. That tells me that I can't have negative exponents. So we started there. Then we went ahead and we subtracted our exponents, the y's and the x's. And finally, we multiplied 2 times 7 to give us negative 14. And that's our final answer. Letter B, I noticed that I have a 15 and negative 3. So I'm going to simplify those first. So negative 3 divided by negative 3, that gives me a 1. So I don't have to really write that 1. If you want, you can put the 1 there, but you don't have to. And then 15 divided by 3, that's going to cancel and give me a 5. So far what I have is 5, c to the 5th, d to the 3rd. All over, I can put the 1, but I'm not going to. C squared, d to the 7th. Now, I'm not done simplifying because I have this d on the top and a d on the bottom. I have a c on the top, and I have some c's on the bottom. So I got to simplify this so I don't have double variables. So when I simplify it, I'll start with the c's. I'm saying 5 minus 2. So I'm left with c to the 3rd. It stays on top because that's where the greater number of c's are. I'm going to do the same thing with the d's. So it's 7 minus 3, which gives me d to the 4th. And that's my final answer. Okay, our letter C has a negative exponent on the outside. So when the negative exponent's on the outside, all we do to make him positive is flip the inside of our parentheses. So I flipped it, so now I have 4 over A. Now it's a positive 3 on the outside. So all I did was flip what was in the parentheses, and that made the outside positive. But I'm not done yet. I got a degree. So now I have 4 to the third, A to the third. Now 4 to the third is different from 4 times 12. 4 to the third is 4 times 4 times 4, which gives us 64. And then we have A to the third. So we're done with that one. Letter D, it has an exponent on the outside. So we're going to distribute that exponent to everyone. And when I have an exponent on the outside, I multiply them. So I'm saying negative 2 to the 5th power. Be careful, we're not saying negative 2 times 5. We're multiplying the exponents. Then I'm saying x to the 3rd times 5 gives me x to the 15th. And then y to the 2nd times 5 gives me y to the 10th. So I can't do anything else with the variables. So there's no variables to cancel. I only have one x and one y, which is good. And then I have negative 2 to the 5th. Negative 2 to the 5th is negative 2 times negative 2 times negative 2 times negative 2 times negative 2 5 times. So I'm going to do that on the side over here. So I'm going to write that 5 times. So negative 2 times negative 2 gives me a 4. Times another negative 2 gives me a negative 8. Times another negative 2 gives me a positive 16. Times another negative 2, we end up with a negative 32. So my final answer would be negative 32, x to the 15th, y to the 10th. So that was it for simplifying. We're just simplifying exponents. The other thing we talked about in class was when we talked about classifying the degree of a polynomial. So we need to first determine, is it a polynomial? And if it is, then state the degree. So it's a yes or no question. So looking at letter A, we need to first know what's a polynomial. Well, a polynomial is just made up of monomials. So if we're looking here, this would not be a monomial because we have division. This would be a monomial because we're saying 3 times x squared. So monomials are numbers and variables that are separated by multiplication that have positive exponents. So this guy is a monomial. This one isn't because it's saying x divided by y. So because both of them are not monomials, this is not a polynomial. So I would just say no. Then I could say because of division. And I'm writing shorthand, so I'm saying because of division. Letter B, we have x to the 5th times y. So this is multiplication. So that is a monomial, check. Then I have 9 times x to the 4th times y to the 3rd, check, that's a monomial. Then I have 2 times x times y, check, that's a monomial. Now, it makes it a polynomial because I have 3 monomials. Okay, so this is a polynomial, yes. And now they're asking, if you said yes, it says state the degree of the polynomial. So I'm looking at each of the monomials and I'm looking for which one has the greatest exponents in it. And I'm going to erase the squares so that we can see the exponents. So this monomial, if I add its exponents, I'm saying 5 plus 1. So the total of 6. This monomial has a total of 7. And this monomial, this is just a 1 and a 1, has a total of 2 degrees. So my highest degree of this polynomial is 7. So then I would just say yes, and the degree of the polynomial is 7. Adding and subtracting polynomial expressions is something that we were very similar with and we're very familiar with. So letter A is a little bit trickier than letter B, And the reason it's trickier is because of the negative sign. So the negative sign just means we have to distribute the negative to everyone. So what that's going to do is change everybody's sign. So when I do that, I'm going to rewrite it, and I like working vertically, so I'm going to say negative a to the third, because I'm switching the sign, plus 3a minus 2. Okay, all I did was switch everybody's sign because of the minus. And now I'm going to work straight down. So I'm saying 2a to the third minus a to the third. That's just saying essentially 2 minus 1. So 2 minus 1 would just leave me with a to the third. 5 plus 3a, or 5a plus 3a gives me 8a. Negative 7 minus 2 gives me negative 9. And that would be my final answer. With adding polynomials, letter B, since we're adding, we don't have to change the signs. I'm just going to take this whole chunk and write it under our first one, so I can working down. Here we go. And I'm just going to work straight down. So I'm saying 4x squared minus 2x squared. That leaves me with 2x squared. Negative 9x minus 5x. That gives me negative 14x. 3 minus 6 leaves me with negative 3. And that was it for adding or subtracting. Multiplying, when we're multiplying, careful, this is different from what we just did because I don't have a symbol between the parentheses. Okay, look here. Here we had symbols. We had symbols, these guys. So that's what told me that I had to add or subtract, that I wasn't multiplying. Over here, we have no symbol between all of these parentheses, between the two sets of parentheses. All it is a multiplication sign. When we're multiplying, we're using the distributive property. And really, we're using the distributive property twice. So I'm going to start with the a, and I'm going to multiply everything in the other parentheses by a. So when I do that, I get a to the third power plus 3a to the second power minus 4a. So then I did the a, we're done with the a. Now I'm going to distribute the 2 to everybody. So it's going to be plus 2a squared plus 6a minus 8. Okay, so that was the multiplying part. Now that I did that, I'm going to combine like terms. Well, nobody has an a third, so I'm just going to write a to the third. There's no other a to the third. I have 3a squared, and I have a 2a squared, and they're both positive, so that's going to give me positive 5a squared. Then I have negative 4a and positive 6a, so that gave me negative 4 plus 6a gives me positive 2a. And the negative 8, he doesn't have a partner, so we'll just write him at the end. Okay, so that was it for that one. B and C are exactly the same, so I'm going to go ahead and jump over to D. So D, very similar to what we just did. The only difference is now we have 3x. So we're going to multiply. We're going to start by multiplying everybody by 3x. Okay, so when I do that, 3x times 2x squared gives me 6x to the third. Careful, make sure that when you multiply variables, you add their exponent. So that was a 2, and my 3x essentially has a 1. That x has an imaginary 1. That's how I got 6x to the third. Then I'm doing 3x minus 4x, so that gives me negative 12x. Then I have 3x times 5, so that gives me positive 15x. So I'm done multiplying everybody by 3x. Now I'm going to go ahead and multiply everybody by negative 1. So when I do that, I get negative 2x squared plus 4x minus 5. And I'm going to combine my like terms. So when I do that, the 6x to the third, he has nobody to combine him with, so I'm just going to rewrite him. There's no other x's to the third. And this guy here should have been a squared. So I'm going to say negative 12x squared, and I have a negative 2x squared. That is going to give me negative 14x squared. Then I have 15x and 4x, so I get positive 19x. And then my last guy is negative 5. So that would be it for that problem. Now, so 5-1, that is all we did. I'll quickly review. We simplified problems that had exponents. So to look at this, if you don't know the rules to the exponents, another place to find all of the rules is in your textbook under section 5-1, and the page for that specifically, if you're looking for the rules of all the exponents, the page, let me look it up real quick. It is page 303, so that's where all of the rules for exponents are. They also work out a couple of examples in that section, so if you want to see more examples worked out in the textbook, you can. It's page 303, and that lists all of the rules for exponents. So I hope this video has been helpful. We also did degree of polynomials, adding and subtracting, and multiplying. And that was all we did in 5-1. Have a wonderful night.